Hello everyone, happy to see you here, welcome back to my channel. Today we have a very interesting, quick and relaxing algebra question. We know that the sum a plus b equal to 12 and a product a times b equal to 14. We need to solve this question for a and b, so if you have your solution, your answer, if you want to check your school knowledge, your algebra skills, you can also solve this question with me. You can also pause the video and write your solution in the comments below, and then we will check our answers. Okay, so let's start. We have system of two equations. First of all, let's express from first equation, let's express our b. So let's start with that. So our first step, so b equal to 12 minus a. So b equal to 12 minus a. And right now let's plug in this b, so this 12 minus a instead of this b to the second equation. So what do we have? We still have this a, and instead of b we plug in this 12 minus a. Yeah, so we have 12 minus a equal to 14. And right now we have an equation with only one variable. We have only a, we don't have a and b, we have only a, so this looks like this is a quadratic equation. So step by step, let's solve this. First of all, a times this parenthesis, so we have 12a minus a square and minus 14 equal to 0. And one really interesting moment, because I just write this 14 on the left side, because right now we have a quadratic equation, but we prefer a little bit different order. So first of all, let's write this minus a square on the first position, minus a square. The next thing, plus 12a, so plus 12a, and minus 14. And everything is great, but this negative sign right here, so we don't like it. We prefer a classic order of signs, so we prefer a positive right here. So let's multiply both sides by minus 1. It helps us because right now we have a classic order of signs. We have a square minus 12a and plus 14 equal to 0. This is a basic quadratic equation. Of course, this is up to you how you prefer solving this type of question. I prefer a classic method of coefficients, because maybe a lot of students here. So this is a basic method of coefficients. So that's why we write that our a equal to 1 from here, our b is equal to minus 12, and our c is equal to 14. Okay, we know all these coefficients. So right now let's solve for discriminant. So our d is equal to b squared minus 4ac. So we know everything, so let's plug in it. So we have b equal to minus 12, so we have b squared, so minus 12 square minus 4 times a times 1 and times c times 14 equal to, so minus 12 square equal to 144 minus, right here we have 56. So our discriminant is positive. This is really great. So we have 88, so greater than the 0. It is really great for us because right here we have two real number roots. So let's plug in everything. Let's plug in it into this formula. So a first and a second equal to our all known formula, minus b plus minus square root of discriminant, and all over to a. So minus b minus 12 plus minus square root of discriminant square root of 88, and all over 2 times a, 2 times 1. Okay, so right now let's simplify this real quick. So we have minus 12 equal to 12 plus minus. Right here my quick suggestion is to express this in a different in another way, because 88, so this is not a table case. This is not like 81. This 88, so we can't get this square root quickly, so that's why we can easily express this 88 in a different way. So just look at it. How can we do this? So we have 88. Of course, this is equal to 4 times 22. But if you have problems with it, if you're struggling with it, you can also divide this 88. So I'm going to show you this right here. So we have 88. Yeah, you divide it by 2. You just divide it step by step by 2, by 2, by 2. So we have 44 divided by 2. We have 22, and of course you can leave it like that because 22 we can't get this square root, so we can write it as 4 times 22. Okay, so we have 4 times 22, and all over 2. Why 4 times 22? Because right now we can write this square root, we can write this as a product of two square roots. So we have 12 plus minus square root of 4 times square root of 22. Okay, we can write it like that, and divided by 2. Right now we have 12 plus minus 2 square root of 22 over 2. And our last step right here, you can also use two methods. You can divide these two by this coefficient and by this one, but I suggest you to factor 2 from our numerator. So in our parentheses we have 6 plus minus square root of 22 and all over 2. And right now we can cancel these two. As a result, we have 6 plus minus square root of 22. This is really great. And right now let's write our a first and a second, and let's solve it for b. So first of all, let's write our a first. Let's write it with the positive sign, doesn't matter. So we have 6 plus square root of 22. And we know that our a second equal to 6 minus square root of 22 with the negative sign. And right now let's go back to the beginning. Where do we have this b? So we have b right here equal to 12 minus a. So but b equal to 12 minus a. So that's why we can solve it for a b first right here. So b first equal to 12 minus a first. So 12 minus a first. So we have b first equal to 12 minus a first equal to 6 plus square root of 22. And right here we have b first equal to 12 minus 6 and minus square root of 22. Right here 12 minus 6 equal to 6. So we have b first equal to, so 1 second please, yeah, right here. So b first equal to 6 minus square root of 22. And we can easily see that our pairs are absolutely symmetrical with each other, because right here 6 plus square root of 22, b first 6 minus square root of 22. And without any problems, right here we can write that our b second equal to 6 plus square root of 22. Of course, you can also check it. Right here we have symmetrical pairs. So let's write our final answer to this question, and in the end let's check real quick our roots. So our answer. So we have two pairs. First pair, we have a first, a b first, so 6 plus square root of 22 and 6 minus square root of 22. And second pair, 6 minus square root of 22, a second, and b second, 6 plus square root of 22. And in the end, let's check it. So let's check it. Let's prove our roots. Let's check it. First of all, on the left side, I'm going to write our system of two equations. So we have a plus b in the beginning, a plus b equal to 12, and ab equal to 14. So let's check it. So first of all, let's check our addition. So we have a plus b equal to one really interesting moment, because right here we have symmetrical pairs, and in our case we have addition and multiplication, and we don't need to check both of these roots, because a plus b is the same as b plus a. Okay, and a times b equal to b times a, so that's why we only need to check, for example, this one. Let's do it. So we have 6 plus square root of 22 plus 6 minus square root of 22. We're gonna cancel this square root of 22, and 6 plus 6 equal to 12. So our addition works perfectly. We have a correct expression. And in the end, let's check real quick our multiplication. So we have parentheses a times b equal to 6 plus square root of 22 and times 6 minus square root of 22. And one really interesting moment, because this is a classic formula. I hope you remember this formula from school. A plus b times a minus b. Okay, so let's do it. I'm going to write it right here, but with x and y, because we already have this a and b. So we have x squared minus y squared equal to x plus y and times x minus y. And this is exactly our case. X plus y, x minus y. But on the left side, we can write it as difference of squares. So that's why we can write it as difference of squares. 6 square minus square root of 22 square equal to, so 6 square equal to 36 minus square root of 22 equal to, so square root of 22 to the power 2 equal to 22. And this is equal to 36 minus 22 equal to 14. And let's look closely. What do we have right here? Yeah, we have this 14. So our roots are great, and our expressions are absolutely correct. So once more, we can easily see a solution to this question. If you have problems with it, you can easily pause the video, because this is not the hard question. This is a classic question for different students. Sometimes I see this type of question on entrance examination in the first level, in easiest level. But of course, a lot of things here. It can be also like a complex root. It can be like a discriminant right here can be negative. So a lot of things. But according to this question, you can see a solution. You can see this right now on your screen. So if you still have any question, write your question in the comments below. It will be really interesting to read about it. Also write your thoughts, write your response, write your questions. Maybe you have a different type of questions. For example, in the school, you can share this question with us in the comments below. It will be really interesting to read about it. So thank you everyone for your time. Take care of yourself. Have a great day. See you in the next videos.